All right. Well, thank you very much for having me again. I was there last year, and it's a real pleasure to be back. So thank you to Kostas and the whole DEVit team. They've done a great job. Yeah, there is a robot again, but you have to wait until the end, right? I want to save batteries. So we'll see about that. And it's a bit of a suicide demo. Sometimes it works and sometimes it doesn't. So we'll see. Yeah, it's a good end of the day demo, I guess. So my name is Julien, and I'm a tech evangelist for AWS. I've been working with them for 2.5 years now, and I focus on AI and machine learning. And yesterday I had the pleasure of running a machine learning workshop for some of you guys. And we went very deep, and we did lots of crazy technical stuff and deep learning training, etc., etc. And that's all very cool. But my talk tonight is AI for developers. And like I say all the time, I really wanted to call it AI for humans, because I want to introduce literally everybody to this. And my point is, you don't need to have 2 PhDs to do this. And this is why AWS has built some services that everybody can use. And I will convince you of that tonight, hopefully. And then we'll see them running on the robot if the robot feels like it. So if you time travel to 1995, which is pretty much when Amazon was created, you would go to the website, and some of you might actually be old enough to remember this, like me. And it looked like this, probably was, Netscape version 1, I guess. And very early on, you would see some personalization, some personal content, right? It was very obvious to the Amazon founding team that the e-commerce experience had to be personalized, to be different, to be more interesting than going into stores. And if you fast forward 2 decades, and a little more actually, to 2017, maybe you would have read this article that came out last year. It's a summary of all the work on recommender systems that Amazon has done over 20 plus years. And it's a very good article if you like machine learning, but the interesting thing, I think, is there's actually a reference to the very first recommender patent that was filed by Amazon in 1998, so 20 years ago, at a time when other big companies didn't even exist. So Amazon has really been doing this for a long time. And over the years, this really has spread to every part of the company. You may be familiar with those robots built by Amazon Robotics. Today we have over 50,000 of those robots moving around 24/7 in our fulfillment centers. And as you can see, they pick up the shelves and carry the shelves to the picking teams, right? To the people who actually prepare the orders. And as you can imagine, this is obviously based on AI and machine learning for route planning, collision avoidance, optimization, etc. So pretty cool. Pretty sturdy robots, because those things are super heavy, as you can imagine. So that's our robotic army, if you want to call it like that. The Amazon Echo, of course, is another example of using machine learning to invent a new family of device. I've got an Echo today, and if it feels like it, we'll use it later on. And of course, these use natural language processing, speech recognition, text-to-speech, etc., etc. All of these things are based on deep learning. This one actually looked like a joke when it came out, and people thought it was really, April's Fool or something. And it's not. It's still being tested. It's drone deliveries, being tested in a couple of locations. And these are not remote controlled. These are fully autonomous drones that take off from the fulfillment center and go and deliver the package in your garden. And so this gentleman here, we'll see him in a second, is quietly waiting for his package, and hopefully the drone will deliver it in the right spot. Hey, you, over there. All right. So again, route planning, image recognition, all that stuff is AI at work. And this is the last one. It made the news recently because it's actually open to the public now. It's called Amazon Go. And did you see what this guy just did? Okay. He walked in with a QR code, picked a sandwich, I guess, and then left. And no one was actually running after him, right? Yeah, which is good. Because he actually didn't steal anything. He just went out, picked some food, and left. And there are a lot of tiny AI-powered cameras on the ceiling that actually look at what you're doing inside the store, what you're picking, what you're putting in your basket, and you leave the store, and within minutes you get your bill. Okay, so if you go to Seattle, you can actually visit it. It's open now. And I tried to mess with it when I was there, and I couldn't. Hopefully, that's not the robot burning. Yeah. If not, I'll just play the robot. Yeah, I couldn't fool it. Basically, I couldn't fool the system. So pretty good. But this is all nice. Amazon is reinventing new ways of shopping and new ways of delivering packages. But I work for AWS, and my mission is to help everybody out there use machine learning, and literally every developer, every data scientist, and to give you tools that let you easily build similar systems, similar customer experiences. Okay, it's not just about Amazon; it's about everyone else. So. Actually, if we look at customer references today, more machine learning is built and run on AWS than anywhere else. And of course, you find the big names, Netflix and NASA and a lot of really big organizations, but also a lot of startups, right, who don't have a lot of, if any, machine learning skills, and because they can't afford to build these teams, they don't want to build these teams, they just want to focus on their product and their user experience. So lots of startups. Actually, didn't fit on one slide, so I needed to add a second one. I didn't want to leave anyone out. Soon it's going to be 3 slides, I guess. So lots of examples, and obviously you'll find lots of details on the AWS website. So the stack today looks like this. We have 3 layers. The first layer, which is the one I'm going to focus on, is called application services. And these are just API-driven services, most of them real-time. And they get the job done with just an API call. And I'm going to obviously show you some demos in a moment, and you will see that. So they're all based on machine learning and deep learning, but you don't need to know the first thing about that. You just call an API, just like you would call an API to create a virtual machine on EC2 or store an object in S3. Right? Just call an API, and again, most of the time, in real time, get an answer. And these are about image processing, video processing, natural language processing, etc. We'll see that in a second. We have deeper layers, again, covered those in the workshop yesterday, that let you train models on your own data, build your own custom solution, but I'm not going to cover those today. Happy to share some more information once we have beers afterwards. So the first service I want to mention is Amazon Recognition. So Amazon Recognition, as the name implies, is about understanding visual content. And it can do many things. Object detection, understanding faces, comparing faces, detecting unsafe or explicit content, celebrity detection, and detecting text and images. So let's look quickly at those features, because obviously we want to see them in action. So object detection is pretty much what you would expect. Pass an image to that API, and in real time you get back some labels with confidence scores. Okay, so these are just examples. You would get many more labels, and actually what you get from pretty much all those services is a JSON answer that contains all the information. So object detection. Facial analysis is about a number of things. Detecting faces, so the location, what we call the bounding box. Okay, so you get the actual coordinates. There's just one face here. There could be many more. And for each face, we get attributes like gender, age range, emotion detection, glasses, beard, mustache, that kind of thing. Okay. And again, we would get that for every face. This is actually a picture from the workshop yesterday. And well, it's a really bad selfie. I'm notoriously bad at taking pictures here. But except for one person standing really in the back, which is half hidden, we really detected everybody, right? And as you can see, we get the bounding box to get the location of the eyes, the nose, etc. And Michael here, where are you, Michael? Are you having beers already? Okay. No, you're over there. All right. So Michael was not sleeping during the workshop. And okay, there's a mistake here, because we all know he's more than 43 years old, but everything else is about correct, right? And we would get this information for pretty much everybody. Face comparison, and again, facial search, if you want to call it like that, is what you would expect. Take 2 pictures and look at all the faces in one picture and try to match them to a face in the second picture. So here, it's 1 versus 3, but again, it could be 10 pictures, 10 faces in the first pictures and 20 in the second, and we would look at all pairs, right? So that little girl on the left is also, it's on the right-hand side of the second picture, so we recognize that with a high score, and the other girls are different girls, okay? So pretty easy to recognize people here. Image moderation is really important if you have user-generated content uploaded to your websites or to your apps. This picture is perfectly okay in some context, right? If you have if it's a fashion website or if all kinds of websites, this is fine. If it's maybe a kid-oriented website, maybe it's not okay. Maybe you don't want those pictures in there. And I guess in some cultures, in some countries, this is never okay. So the service will actually tell you what's in there, swimwear or nudity or explicit stuff, which I'm not going to show you. You can test this on your own. But yes, it works. And then based on that and based on your business context, you can decide to use it or not. Okay? Celebrity recognition, right? Yeah, come on, I had to do that, right? Rest in peace, my friend. So celebrity recognition is exactly what you would think. We built a collection of movie stars and artists and businessmen and politicians, etc. All kinds of famous people in all kinds of countries, not just baseball players, thank God. And we can detect that they are this exact person. And in the answer, you also get maybe a link to a Wikipedia page with more information, or you get a link to an IMDb page, etc. Just more context. In text in image, pretty obvious what this does. It will extract text from an image. And again, it will give you the bounding box, the text itself, and if you have multiple lines, it will give you the different lines and the exact locations, okay? So this is not an OCR service. I always get this question. It might very well work. I know some customers are using it for passports and identity cards and that kind of thing, and it works well for them. You have to try it, right? And I'm going to use it in a few minutes on my own handwriting, which is why it's probably a suicide demo. It's not supposed to read it, but okay, we'll figure it out in a few minutes. Okay, it's mostly about, I would say, print text, block letters, etc. If you have very fancy fonts, it might not pick it up. Okay, so we'll see recognition in action in a minute. Recognition video is the extension of this to video files, and this could be archives, video archives that you have in Amazon S3, or this could be streams, okay? And you can do pretty much everything you did with recognition with a couple of new things like activity detection, because of course we have the time dimension. So we can figure out if a person is running or falling, right? If you have just one image, it's difficult. If you have multiple images, you can do that. And we can, of course, do tracking. We can follow a person in a video because, again, we have the multiple pictures. Okay? So I don't know if some of you watched the royal wedding in the UK a couple of weeks ago, but if you were watching Sky News actually used recognition video to identify celebrities and royalties as they went into the church. Okay, just real-time recognition. So I guess David Beckham, anybody would recognize David Beckham. But no offense to the royal family of Lesotho. But first of all, I had no idea there was a royal family there. And if you asked me the name of the king or the prince, I wouldn't know. And even maybe a journalist wouldn't know. So you can't know everyone, but recognition video is pretty good with celebrities. So this is the kind of app you would like to build, I guess. See, it's okay. You've got this family showing up. right? And well, that girl has a package. And we can see those different persons. And like I said, we can track them in the frame, frame by frame. And they're showing up at your front door. OK, so one of them is matched. OK, that's Bob right there. Maybe it's your colleague. OK, so you match him because you know him. Is your home camera as a picture of his face, which he agreed to give you. And you don't know his wife, and you don't know his kids. But that's OK. You know Bob. So maybe your home camera detects Bob, and your smart home says, hey, Bob's at the door. OK, and you say, fine, open the door. And Bob and his family come in. And someone is filming this birthday party, which maybe you want to index later on, extract keywords, et cetera, and you can find this information again. And if you want to know why these two guys are arm wrestling in the corner, I have absolutely no idea, right? I don't know. It's got to be a private joke. So this is nice, right? I mean, this is a cool app to build. There's definitely a business case for that. How difficult is it to do that, right? Well, not very is the answer. You can, if you have a camera, OK, this could be your front door camera. It will stream a video to a service called Kinesis Video Streams, which is a managed service, a managed streaming service that receives the streaming video, forwards it directly to recognition video, and you could have the face collection that you built with your own family and your friends. Okay, so Bob's picture is in your face collection, and recognition reading the stream will actually identify Bob, okay? And it will output this information to another stream, and then you could trigger a Lambda function in AWS, a small piece of code, sending a notification saying, hey, Bob's at the door, okay? It could send you an email or an SMS, or it could activate something inside your smart home, okay? How many servers do you need to run this? 0. Okay, all that stuff is fully managed. So how about we give it a try? So what I'm going to do here, I've got a webcam, and I'm going to try and capture it with a native client that I built. Okay, it's based on JStreamer, and I can just run this thing. Which is called, oh, come on. Here it is. OK, so what this does is, and I should stand in front of it, I guess, otherwise you won't see much. So it starts capturing the video stream, right, from my webcam. And it's exactly what we saw in the previous slide. It pushes it to Kinesis Video Streams, which sends it to recognition video. So if I go to the console here, and I reload that page, and hoping we have enough bandwidth here, we should see that stream showing up. Okay, and of course, it's not strictly, here we go, it's not strictly real time. Okay, there's a bit of lag because there's not a lot of bandwidth, and there's not a lot of bandwidth, right? So, come on, I'm moving. Let's refresh this. Oh, come on. It is sending, right? Yes. Okay. Let's try to reload that page again. Yeah, usually it lags maybe, I don't know, 20, 30 seconds. But, looks like it has a little more trouble here. Maybe if I can lower the resolution, let's give it a try. Just send a little less data. No, it doesn't want to open the camera at this frame rate. Oh, come on. OK, let's try again. We do have Wi-Fi, yeah? OK. Come on, let's give it 10 seconds, and then we move on. Come on. Not much work. No, I think it's stuck. Okay. Can I fast forward it? Okay, that's it. I'm impatient. Okay, so I think I'm just killing the Wi-Fi here. Okay, well, oh, no, see? Now it's moving, okay. Oh, you can see me moving, right? And there's about 18-second delay. All right, you saw it moving, but yes, that's the problem with the cloud. You do need some bandwidth, right? You do need a network connection. And I guess you guys are just busy watching YouTube videos and eating all my bandwidth, right? Steve Jobs actually yelled during a keynote once. You've probably seen this one. He yelled at the audience with like 10,000 people, say, okay, shut, he was pretty rude about it. Just shut every Wi-Fi device in the room. And I was like, oh my God. But okay, I'm not Steve Jobs, so I'm not going to do that. The next service I want to talk about is Poly. And Poly is a text-to-speech service. So it's pretty easy, right? You have a text string. You select, it could be in 25 languages. And you select a voice. We have 53 voices now, I think. So male, female in those different languages, and call an API, and in real time you get the sound file back. So of course it's about quality, right? It's about having, and let's try to have sound here. It's about, oops.
40 price of this book.
Oops.
The price of this book is 45 euros.
So you can have natural sounding voices, but you can also use SSML, which is a markup language, to actually change the intonation, the speed, and just customize the way the text is pronounced. Okay, so this is another example.
The price of this book is 45 euros.
What's the price of the book? Yeah, not everybody's sleeping. Okay, good. Here's another demo. It's a new feature that we added not too long ago. And this one is about, oops. This one is about a breathing effect. So I want to show you this. It's quite nice. Okay, so SSML is a markup language, like I said. So let's just copy this thing here, and let's listen to it.
Wow, that was quite fast. I almost beat my personal best time on this track.
Okay, so see how you can actually make it even more natural by adding that out-of-breath effect. You can also basically add automatic breathing if you want, and we have good audio quality now, so we could actually hopefully listen to that.
Amazon Poly is a service that turns text into lifelike speech, allowing you to create applications that talk and build entirely new categories of speech-enabled products. Amazon Poly is a text-to-speech service that uses advanced deep learning technologies to synthesize speech that sounds like a human voice, with dozens of lifelike voices across a variety of languages. You can select the ideal voice and build speech-enabled applications that work in many different countries.
Okay, so you have to pay attention, but you hear the breathing. It's with a system like this, it's difficult. If you're in front of the laptop, you hear it a little better. So again, the idea is really to make the voice as human-like as possible, and this breathing effect I think is quite cool. We have another service called Amazon Translate. I don't know if I even need to explain what it does. Okay, real-time translation. These are the languages we support today. So we can translate from English to Spanish, Portuguese, German, French, Arabic, and simplified Chinese, and from those 6 back to English. Okay, this was launched at reInvent just a few months ago. So we're adding more languages, and all these languages on the right are also coming. So no Greek, I know. Everywhere I go, people tell me, "Oh, my language is not in there." It's like, okay, well, keep asking. It will be there. Okay, there's no reason why your language would not be there. Okay, let's do a quick demo of that one. quite easy. Okay, so I don't speak Chinese, so okay, let's do the Chinese example. So I've got a prepared, and I'm using the AWS CLI here. Okay, so if you speak Chinese, you can actually check this translation. And as you can see, it's real time. And like I said, I don't speak Chinese, but if I look at the translation, okay, it looks like proper English to me. So it would be enough for me to understand what this article or this thing is actually talking about. This is from a Chinese newspaper, this paragraph. It would be enough for me to understand. And if you really want it to be perfect, you could run Amazon Translate first, and you could have a professional interpreter just read that again and fix the few mistakes or the few things that you don't like about the text. It would still be much faster than translating everything from scratch. Okay, so here again I use the AWS CLI, but you can use any SDK to do this. Okay, all right, 2 more, and then we can start doing silly things. Transcribe is the reverse operation of poly. So poly is text to speech. Transcribe is speech to text. Okay, so this one is not real time, so it's batch. And it supports English and Spanish. It's quite recent. It was also launched at reInvent a few months ago. It will give you the text, obviously. It will give you punctuation. It will give you the timestamps. So if you want to do captioning, for example, it's interesting. And it supports high-quality audio, but low-quality audio as well, like telephony audio, which is very important for our customers who want to transcribe customer calls, right, from call centers. And then they want to run analytics on that text to understand, is the person happy or not, and why did that person call, what was the problem, etc. Okay, so it's important to support phone calls. Okay, and it supports multiple speakers, so it will not recognize the actual people, of course, but it will tell you, okay, speaker 1, or speaker 2, back to speaker 1, etc. So you can actually see how many people are in that conversation. Okay, and the last one I want to mention is called Comprehend. And Comprehend is basically natural language processing. Again, in real time, call an API on a piece of text, and it will extract entities. So what is this text about? Okay, who are the persons, who are the organizations, the companies that are mentioned, and extra information, times and places and quantities, etc. It will perform language detection. It can detect 100 languages accurately, and it will do sentiment analysis. Okay, so you could, for example, combine transcribe and comprehend, right? Take a phone call, transcribe it to text, and then run sentiment analysis with comprehend to figure out if this conversation was a happy one or an unhappy one. Okay, so it's fun to combine those things. So let's try a final demo before we look at the robot. So this is my $1 billion startup ID, right? And you can invest if you want. Right? Just talk to me after the conference. So my idea is I would like, maybe in my car, okay, I would like to have a camera that reads text on billboards, right? And even in languages that I don't understand, okay? So I could be driving around in, I don't know, Germany, let's say, or Spain, or Portugal, and that camera would detect text in billboards and translate them. Okay, maybe it would give me, directions. Who knows? Interesting information on those billboards. So, of course, we need a sample to do this. So this is my example. All right. Yeah, I guess you would like that. I figured. It's a little dark, but you can still read it. Believe it or not, this is a Las Vegas sign. Right? It's a real sign, and yeah. If you've been to Las Vegas, you understand why. But they had to take it down because residents complained that it gave the neighborhood a bad reputation. So people in Las Vegas complaining about alcohol, I don't know. It doesn't sound very credible to me. But anyway, that's what I heard. So what I would like to do here is extract the text, detect the language, and then translate it to multiple languages and then speak those translations. So surely this has to be a lot of work, right? So how much work is that? And yes, I use VI, and if you don't like it, just, okay. All right, anyway. I was born in the previous century, that's why. So it's 33 lines of code, including white space, okay? And it's pretty much one API call to do each thing. And I'm combining, as you can see, recognition, comprehend, translate, and poly to do this. And that's all there is to it. So let's try and run it.
Alcohol, it's cheaper than therapy.
Alcohol es más barato que la terapia.
Álcool é mais barato que terapia.
Alcool, c'est moins cher que la thérapie.
I got that one.
Alkohol, es ist billiger als Therapie.
Yeah. Okay. See, that's one thing we can all agree on. Thank you. Okay, so this is all fine, but I'm running stuff from my laptop. So now, okay, we want to do more, okay? We want to do more, and I had one failed demo already, so maybe I can raise the bar and fail 2 demos. So if you were there last year, you've seen this thing before. Actually, I should go and get it. All right, buddy. All right, you've seen that guy before, okay? So let's give it a test really quick. Alexa, open Johnny Pie.
Johnny Pie is at your command. What would you like him to do?
Move forward.
Okay.
All right. Goodbye. Okay, so,
Johnny Pie.
yeah. Now shut up now. Okay. Okay, so here's Johnny, right? Same old. No one has managed to destroy it in my many trips. So what do we have here? Let's try to give it a voice, hoping we have enough battery for this. If not, we'll manage it. So last year, I had a remote control for this thing, if you remember. I had an Arduino remote control for it, which was fun, but I figured, hey, it's not a toy, you know. He is a proper person. I should show him respect. So showing respect to somebody means talking to that person, right? And he's a little person. So I wrote an Alexa skill. Okay, let's try to give some more sound. I wrote an Alexa skill that hopefully understands what I'm trying to say and posts IoT messages, right? We have a service called AWS IoT. It's a managed service. And it sends MQTT messages, which is a protocol, an industrial protocol, standard protocol. So it sends IoT messages from the AWS cloud to Johnny. And so Johnny is actually reading, waiting for orders to come into MQTT topics, which are really message queues, if you want to call them like that, okay? And I've got different message queues to do different things. So let's try something else. Alexa, ask Johnny Pie to go forward.
I don't know that.
Okay. Alexa, open Johnny Pie.
Johnny Pie is at your command. What would you like him to do?
Go forward.
Okay.
Go forward.
Okay.
Turn left.
Okay.
Turn right.
Okay.
Go forward.
Okay.
Thank you. Okay, so this is fine.
Please try again.
So last year, we failed really bad at face recognition because the lights are very hostile. But this time, we're going to win, right? I know it. So, and now I know how to make it work. Alexa, open Johnny Pie.
Johnny Pie is at your command. What would you like him to do?
Do you see faces?
Okay.
I'm confident. Okay, so it's taking a picture, sending it to recognition, and let's see, sending tweets as well. So let's see if we got a tweet. All right. So we can remove those slides. Oh, and of course, I lost my connection. Fine. That's why. Okay. Oh, come on. Ah, it is connected. Come on. Okay, let's just reboot it. This is really, really sensitive to Wi-Fi. Okay, that should be enough. I think it's the end of the day for Wi-Fi. Oh, come on. Oh, it worked fine earlier. Yep. Okay, so plan B. Whoops. Trying to have 4G reception underground is going to be interesting. Nope. Okay, one last try. Oh, do we have an Ethernet cable here? No. Okay, so that doesn't work either. All right.
You can take mine.
No, but I need to set it up. You know, there's some setup here. No, I can't do it like that. Thanks. Oh, here we are. Okay. So switch. Come on. No, but it looks like I'm connected now, so. If I can connect to my phone here. Oops. Okay, so we should be back. Come on, start. Alexa, open Johnny Pie.
John Pye is at your command. What would you like him to do?
Do you see faces?
Please tell me what to do. For example, go forward.
Do you see faces?
Okay.
Okay, that should be enough. Okay, so 3 faces have been detected. Okay, so this is the other one that didn't work. Yes, see? All right, 3 faces have been detected. Okay, so now we're going to try simpler stuff. Okay? And I need to shout, Alexa, open Johnny Pie.
John Pie is at your command. What would you like him to do?
Which language is this?
Okay.
Okay, so, right? You should know. What did it figure out? Yeah? See? I don't suck that much. Alexa, open Johnny Pie. Come on, I'm shouting when I'm not mad. Alexa, open Johnny Pie.
John Pie is at your command. What would you like him to do?
Read this text.
Okay.
Ah, it missed one letter. Okay. All right. It missed, yeah, I cut the end, but the rest is good, right? Yeah, so that's recognition text, which is not supposed to read handwriting. So, okay, let's try to fail some more. Alexa, open Johnny Pie. Alexa, open Johnny Pie.
John Pie is at your command. What would you like him to do?
Translate this to English.
I'm afraid I can't do that.
Alexa, open Johnny Pie.
Okay.
What did you understand? Alexa, open Johnny Pie. I'm too far. There's too much echo. Need to run. Alexa, open Johnny Pie.
Johnny Pie is at your command. What would you like him to do?
Translate the text to English.
This language is not supported.
Okay? Alexa, open Johnny Pie.
Johnny Pie is at your command. What would you like him to do?
Translate this text to English.
Okay.
All right. This is the harder one, actually, so we'll see. Ah, this is very funny. I'll explain why. Okay, so it translates Ich spreche Deutsch as I speak English. Awesome. All right. And the reason for this, apparently, is if it catches the point, okay, it does translate this properly. If the point is missing, there's some kind of bug. I've reported it. Okay, let's try another one. Okay. Alexa, open Johnny Pie.
Johnny Pie is at your command. What would you like him to do?
Translate this text to German.
Okay.
All right, should be enough. Yeah. All right, that one worked, right? Ich kann lesen. It's proper German. I know you don't like German here, but it's proper German. All right? Okay, well, that was fun, right? That was super silly. But we made it, right? Against Wi-Fi and lots of other problems. So, oh, yeah, maybe a final one. Does anybody have a bottle of water or any kind of object? Yeah, oh, empty, doesn't matter. Okay, thank you. Right. Alexa, open Johnny Pie.
Johnny Pie is at your command. What would you like him to do?
Do you see an object?
Okay.
Yeah, close enough. Close enough. So here, I'm not using recognition. I'm using a deep learning model, a local model. Remember last year, I did it with a baseball, right? But I made some more improvements. This is now way, way faster, as you could see. It's a Raspberry Pi, and it can actually detect the object in 1 second, so, which is probably 4 times faster than what we did before. And it says it's a soda bottle or a beer bottle, which, again, is pretty close, because this model has been trained on 1,000 categories, right? So if the top category is soda bottle, 23-something%, you know, I guess it's close enough. And we should have a tweet for that one as well. Yeah? Yeah, and it's not a great picture, and there's some stuff in the background, so it still gets it, okay? So there you go, a Raspberry Pi, 1 gigabyte of memory, a very small CPU, and you can do all of this, right? And this kit, like I probably said last year, is about $200, including everything. Yeah, a little more for the batteries, if you want them to last for a few minutes. But you can do stuff like this. And the code for all of this, I guarantee, is just as simple as what you saw before, okay? So it's just, all of it is Python. The server that is running on Johnny to process everything is probably 200 lines of code. And the Alexa skill is very simple. Okay, you just need network connectivity for everything, but we made it. There's a long series of posts on this stuff on my blog. I've been working on this for a year, and something tells me I'm going to be working on it for a while. So that's the summary for today. High-level services, we covered most of them, just an API call away, and you can use them in your apps, in your web apps, in your mobile apps. You can use them on small devices. You can use them on powerful servers, but the code is just super, super simple. All of these services are available in the free tier in AWS, so if you have a new account, you can test all those services for free for 12 months. So why not go and give them a try? You can have lots of fun with that. And build your own silly demos that fail. If you want to learn more, these are the URLs and the AWS blog with technical examples, etc. My own blog on Medium, which has a lot of content on machine learning, deep learning, Johnny doing silly things, and video that I actually record at home that work because I have good Wi-Fi. Again, everything's on GitLab now. Yes. More power to GitHub, but I felt for me it was time to move. And if you want to stay in touch, the best way is probably to catch me on Twitter at Julien Simon, right? Or connect on LinkedIn, but please don't send me email. It will just make me even more late. All right. It was a bit of a mess, but I hope it was good fun. And well, that's the end of the conference. So Kostas and everybody, thanks again for bringing me here. It was great. I just wish I could stay longer. Yeah. But I'll see you at the party. I'll be here tonight. So now it's time for beers, right? Thank you so much.